Hello, Year 12 Maths lesson video for exercise 48. We're going to try and find the tangent to a curve, and more particularly the equation of a tangent to a curve. And of course, here's my curve here, this curved line here. And at this point here, I'd be presuming it at 0.5. This is obviously x is 0.5. We're trying to find the tangent at that point. And the tangent of the line, it just touches the curve. We want the equation of those tangents. So let's have a go at a few things. Now, first of all, we've got to start here. It says write down the formula of a straight line with gradient m going through the point x1, y1. Well, this is a set formula you want to know. So see if you can write that down. Use this formula to find the equation of the line with gradient 2, which passes through the point. So again, you are going to use this first formula, but then you have to rearrange your equation at the end to say y equals mx plus c. And the third one, now of the gradient, is minus a half, passing through this minus 2.7. So see if you can do those three. I'm going to pause the video and I want you to do those three, then I'll put the answers up. So first of all, let's look at these. This formula that you were meant to know, y minus y1 equals mx minus x1, this is old stuff which we did at the beginning of year 12, so you should be able to do that. Now, if you substitute into this y minus the minus 1, so that's y plus 1, equals m, that's 2x minus 4, and then rearrange that. According to me, you get y equals 2x minus 9. And if you do a similar thing for part 3, according to me, you get x plus 2y equals 12. Notice again, it's so many x plus so many y equals a number. That's the format they wanted. So those skills are very important when you're finding equations of tangents to lines. So let's have a go at this. So we often need equations of tangents to a curve. The first thing we need to know is what a tangent to a curve actually is. There's one example one. So at this point, I'm suggesting it just touches, and you want to find that equation. And the important thing to note here is if I know the gradient of the black line, then effectively I also know the gradient of my red line, because the gradient at this particular point of the black and the red line are the same. The tangent and the curve are the same gradient at this point. And of course, the way we find the equation, the gradient of a curve, is we are going to find dy by dx. And dy by dx will tell me the gradient of the curve. And that gradient of the curve will be the same as the gradient of my point. So this is a different curve. Notice I will also need to know the x and the y values. So the x values and the y values. Now at this point here, it's fairly obvious. You can see from the picture. It's at the point minus 1, minus 2. So here you'd know your x and your y values. Presumably you're given the y equals formula. And if you're given the y equals formula, you can find your y by the x. So you're already halfway there. Thirdly then, you substitute your x value. Now in this case it'd be minus 1. And you substitute it into your dy by dx formula. And it gives you your gradient. And we call that m. And then you can use this y minus y1 formula. And that will get you the equation of a tangent. So let's have a go at this one. First of all, my equation says y equals this. So if I was doing this, my very first step is to write dy by dx equals. You should know it's 3x squared. Now if I add so if I bring that to the front, I get plus 6x. I nearly integrated then. Minus 2. So I've got my dy by dx. It's at the point minus 1. So I just kind of write when x equals minus 1 dy by dx. Well, minus 1 squared is 1, so 3 times that is 3. Plus 6 times minus 1 is minus 6. Minus another 2. I reckon that's minus 5. Yeah, I reckon it's minus 5. And now at this stage, I essentially know that m is minus 5. So I've got my equation y minus y1 equals m x minus x1. And I substitute all those bits and bobs in. Y, what was my y? y1 was 3. Y minus 3 equals m minus 5 x minus a minus 1. Well, that's a plus 1. So y minus 3 is minus 5x, and multiplying out the bracket. Obviously there's 2 bits to do. That's minus 5. And it says write it in the form ax plus byc. So I'm going to move the 5x over there. 5x plus the y and then I want the 3 over there. I reckon equals minus 2 when I do that. (5x plus y) equals minus 2. Good. And there's a picture of it. You can see the gradient is negative. It's going down. I wouldn't have known it looked like that without drawing the curve. And of course, you know, it's not always easy to draw the curve. So I've drawn the curve just to show you what it is we're hoping to do there. Next question. Now, the next question basically relies on us knowing what is meant by a normal. And a normal essentially is the perpendicular to the original curve or the original tangent. So here in my blue line it's y equals x squared, and my tangent at the point x is 1. You can see it drawn there quite happily. This is the tangent, and my normal is the one that goes at right angles to it, and that is the definition of a normal. It's a weird word. You wouldn't really associate it as meaning at right angles to the original thing, but you know, a normal is at right angles to. So it's at right angles to the tangent. So just be aware of this. This is our formula for calculating its gradient. You might have been told about this being its negative reciprocal. So some people prefer thinking of it like that, negative reciprocal, and I've no problem with that at all. So if I know this gradient, look, I'm looking at that, it goes 1 across 2 up. So just by doing that there, I reckon this has got a gradient of 2. Now if I write that as m1 equals 2, because I'm going to now flip it upside down, so m2 equals, I've got to make it a minus as well, minus a half. So this line has got a gradient of minus a half. Just be aware that the relationship between these two things. We will come to questions no doubt like that in a bit. First I've got a completely different question. These are very specific tangents and normals. So find the tangent and normal equations of the curve y equals x squared minus 6x. Okay, that's the very first job. dy by dx equals, and I get 2x minus 6 when I do that. 2x minus 6. And therefore if I substitute x equals 3 in, and this is why I knew it was going to be a bit dodgy, dy by dx at this point is 2 times 3, which is 6, minus 6 equals 0. So you've got to think to yourself, what's a gradient of 0 actually mean? Well, essentially it means, well, x squared minus 6x. I know it looks roughly like that as a curve, and that 3 is there, and you can see actually we're right, we found the point which is a minimum point. So whenever you get a gradient of 0, the tangent, and this is of course the tangent here, the tangent is just the y value at which it crosses, because it goes straight across. So all I need then is to know the y value. I don't know the y value actually. Y equals, it says x is 3, so I'm going to do 3 squared minus 6 times 3. That's 9 minus 18, that's minus 9. So the tangent is actually just y equals minus 9. It's a surprisingly simple answer if you have a gradient of 0, because it just goes straight across. So the gradient has no effect. Remember, what we really are doing is finding an equation of the form y equals mx plus c, and there's no gradient, so all of that effectively disappears, and it's just y equals a constant. Now, just bear in mind, the normal to this goes straight up and down, because it's a right angle. So if that's a vertical line, sorry, a horizontal line, this must be the vertical line. So the normal will actually be straight up and down, and you write that, and you notice why I've done it. X equals 3. So we knew it crossed this point here. It said x was 3, and it basically is a line that goes all the way up and down through this line x equals 3, and that is the equation. So this is my tangent line, and this is my normal line, and which is what I've got there. Good. So in this question it says find the equation of the normal to this line. Now the very first thing, I don't like this. It's got this divide by root x, so you're going to have to get rid of this division, and that division really means divide all 3 bits by the root x, and root x of course is x to the half, so, and you have to take away the powers, so that's really like x to the 2.5 plus 6x to the 0.5 minus 1x x to the minus. I've done decimals, so I'll keep doing decimals, but obviously fractions would be probably better. So anyway, so first thing I'm going to do is find dy by dx, and that's 2.5 x to the 1.5, knock off a power, plus 3x to the minus 0.5 minus, plus 0.5x, minus times a minus, x to the minus 1.5. And what am I substituting in? X is 1. So when x is 1, therefore dy by dx equals, and the great thing about x is 1, 1 to the nth power is 1, so I can just ignore it effectively. 2.5 plus 3 plus 0.5. And what's that give me? That looks like it gives me 6. Now what's the equation of the normal? So don't forget, m1 equals 6, but m2 is minus 1/6. So therefore I need to substitute this into my equation. Y minus y1 equals mx minus x1. What was it was 1 and 6. Okay, so y minus 6 equals minus a sixth x minus 1. Move the 6 over, gives me 6y minus 36 equals minus x minus 1 times 1 is plus 1. So x plus 6y equals 37. X plus 6y equals 37, good. Find the equation of the normal, so another equation I want normal. So this is my equation. Again, write that initially. Y equals 6x to the minus 2 minus 5. Find dy by dx. Bring the minus 2 to the front. Minus 12, knock off a power. X to the minus 3. And when you differentiate minus 5, it disappears. So where x equals 2, a couple of things. I don't really know what y is yet. I'll need that in a bit. X equals 2. Therefore, dy by dx equals minus 12. Now, just bear this in mind, this actually means minus 12 over x cubed. So I could just do this here, minus 12 over 2 cubed is minus 12 over 8, which looks to me to be minus 3 over 2. And that's what m1 is, minus 3 over 2. So turn it upside down and change the sign, m2 is 2/3. So what's that mean? Well, I need a y value at x is 2. Because I don't think it tells me, no, I can't see it there. Now this again means 6 over x squared, so it's 6 over 2 squared, which is 4, minus 5. 6 over 4 is 1.5. Minus 5 sounds like, well, this is really 3 over 2, I suppose. And this is like 10 over 2, so you can see this is, that's a 2, is minus 7 over 2. So y minus y1 equals m x minus x1. And of course you could have done all that on your calculator just now, just typed it in and got minus 7 over 2. Well, minus and minus is plus 7 over 2. What was my m? That's the one I want, 2/3. X minus, what was my x1? My x1 was 2. Multiply everything by 3. We'll multiply everything by 3. In fact, I'm tempted to multiply everything by 6. I've got a fraction here as well, so I'm going to times everything by 6. Now, times this by 6, I get 6y. Times this by 6, I get plus 21. Times this by 6, I get 4. Lots of x minus 2. There's other ways to do that, so you could have done this at the traditional way which I've shown you. 6y plus 21 equals 4x minus 8. It says write it, so I'm going to write 4x minus 6y. Minus 8 goes over, it becomes plus 29. They want it's all on the same side. So I reckon minus 29 equals 0. No idea if that's the right answer. Yes, it is. There you go. Look, we'll probably do a few more questions than that, but that's a good intro into equations of tangents to curves. So that's exercise 14a in the textbook, which we'll do in class.